Alright, so today we are going to work on our last set of inequalities. So please remember you got a quiz coming up your next class. Sorry I couldn't be with you today, but I'm going to go through 3 problems with you guys today. We started this a little bit in class yesterday, and you can use these 3 problems as you are going through the worksheet for your practice during your block period. So this is 1.7 rational inequalities. And first things first with rational inequalities, every single time that you solve one of these, what you first need to do is you need to find the zeros in the numerator and find the undefined in the denominator. Okay. So all that means is in the numerator, once you get the numerator factored, you need to set each factor equal to 0 and solve for x. And then in the denominator, once you get that factored, you need to set each of those factors equal to 0 and solve for x. Once you find all of those, you can approach this problem the exact same way as we were when we were working on polynomial inequalities in section 1.6. Okay? So we'll run through these few examples and hopefully that'll give you an idea of how to work on the practice when you're done. So let's start out here with example 1, and let's see what we can do. So for example 1, we're going to try x squared minus 5x minus 6 divided by x squared minus 16 is less than or equal to 0. Okay. So as we try this problem, one of the first things that we're going to want to make sure is that the right side is equal to 0, which is true. And then we're also going to want to make sure that on the left side, all we have is just one fraction. Okay. It is already the case on this problem, but on the next 2 that we see, we're going to need to do a little bit of extra work before we get to that point. So I just want to try and get you guys in the habit of looking for that. Okay. So what I'm going to start out by doing is I'm going to factor the top and the bottom of this. Okay, both of these you can use the shortcut. So on the top, 2 factors of negative 6 that add up to negative 5, or negative 6 and 1. And then on the bottom we have a difference of perfect squares. So x squared minus 16 is going to factor as x plus 4 times x minus 4. Okay. Once we get to here, this is good. Now we can start looking for the zeros from the numerator and the undefineds from the denominator. Okay, the 2 zeros from the numerator are going to be x equals 6 and x equals negative 1, and the 2 undefineds from the denominator are going to be x equals negative 4 and x equals positive 4. Okay, so we got one side equal to 0, we made sure it was one fraction, we factored the top and the bottom, we found the zeros, and we found the undefined. Everything from this point forward is going to be the exact same as what we were doing with polynomial inequalities. Unfortunately for us, we just have a few more things to test on this problem. So what we're going to do is we're going to go ahead and put all of these on a number line in order. We'll have negative 4, our next one's going to be negative 1, we'll have 4, and we'll have 6, and we're going to pick a test value off to the left and in between, and then off to the right for each one of these intervals. So let's go with negative 5 over here. Let's try negative 2. Let's try x equals 0. Let's try x equals 5. And then over here, let's try x equals 7. Okay, so what we're going to do is we're going to plug in these test values, and we're going to see when we're done, do we get an answer that is positive or negative? Because what we're trying to find here is all the values of x that make this thing less than 0. Okay, so let's start out with negative 5. Now nicely for us, this is all factored. So all we need to do is plug in to these parentheses and see what values you get. And then when we're done, we can evaluate it to see whether it's positive or negative. So let's try negative 5. If I plug in negative 5 right here, negative 5 minus 6, that is a negative number. Okay, negative 5 plus 1, that is a negative number. Negative 5 plus 4, that's a negative number. And negative 5 minus 4 is a negative number. So when I do this, negative times a negative is a positive, divided by another positive is going to end up with a positive number. Okay. Let's move on to our next test. Negative 2 minus 6. We've got negative. Okay, I'm not going to say this every time. We're just going to do the math. Next one will be negative. I'm sorry. Yes, next one will be negative. Okay, next one will be positive. And then we are negative. So up on top, negative times negative is positive. On the bottom, positive times a negative is a negative. When we divide them, we're going to get a negative. Okay, when we try 0, negative, positive, positive, negative, which is going to result in a negative divided by a negative, which gives us a positive. Okay, try 5, we get negative, positive, positive, positive. Okay, when we divide all of these, we get a negative on top and a positive on the bottom, which is going to give us a negative. And then last but not least, when we try 7, we'll get positive, positive, divided by positive times positive, which will result in a positive divided by positive, which gives us a positive answer. Okay. So when we're done, the last thing that we need to do to put this in an interval notation is we need to think about what do we actually care about here. As I stated earlier, we are looking for numbers that are less than or equal to 0, which would mean any number that is negative. So our two intervals where we are negative for this problem would be right here and right here, which we're all going to have closed circles because we are or equal to. If we describe these two intervals right here in interval notation, what we're going to have is negative 4 to 1, negative 4 to negative 1, sorry, both with brackets because we're including union, bracket 4 to 6, bracket. Okay, so if we pick any numbers that are in those intervals and plug them in, we will get negative numbers on the left side of this inequality, so they will be less than or equal to 0. And then if I pick any numbers that are outside of these two intervals, I will get a positive number when I evaluate the left side of the inequality, which would make the inequality false. Okay, I'll show you the second example in my next video.